All right, our next functional group is that of the acid group. And an acid group looks like this, and you should actually recognize the two pieces that make up this acid group, because you can see the carbonyl group that we talked about with aldehydes and ketones right here, and you can also see the hydroxy group over here that we talked about with alcohols. But in an acid, the doubly bonded oxygen and the OH are both bonded to the same carbon, and when they are both bonded to the same carbon, the whole thing together is called a carboxyl group, okay? A carboxyl group or an acid is made by oxidizing an aldehyde. Now, I have the aldehyde written this way. That is the same thing as this. So you want to make sure you notice the difference between how this is written. If you see it written as RCHO, that is an aldehyde. And if you see it written as a COH, now that's going to be an alcohol. Okay, so it depends which order those are written in. If it's written as an OH, it's an alcohol. If it's written as an HO, it's an aldehyde. So I've written it as CHO because this is an aldehyde with a doubly bonded oxygen. When I oxidize that in the presence of a catalyst, I will form a carboxylic acid. So you will see it written this way. You will also see it written like this. So you may see it written with the actual bonds, or you may just see the CO2 and then the H. So be sure that you're able to recognize it either way. When we name it, this is probably one of the easiest ones to name, because I'm just going to name it as some sort of an oic acid. So here, for example, just like in my other, with my aldehydes, where I always had to start there with a number 1 with an acid group, that wherever that acid group is, that's going to be number 1. So this is my number 1 carbon right here, and I'm going to go 1, 2, 3, 4, 5. So I have a pentane as my base. You can see that I've got a methyl group on the number 4. So this is a 4-methyl. And then I name it as a pentanoic acid. An acid is a separate word. So whatever the base group is, you add OIC, and then you add the word acid. A 4-methyl pentanoic acid. Now you'll notice that an acid isn't going to be any place else but on the number 1 carbon, because this carbon can only have one other thing attached to it. It can't possibly be in the middle of a chain, nor can you have it on any kind of a ring, because you've got to have 3 bonds available for that. And in a ring, a carbon automatically already has 2 bonds. So it's only going to be on the end of a chain like this. It is also possible that you can have a multiple bond in here. And so again, you've got to give this acid the lowest possible number. So that's going to be number 1. If I look here, I have a chlorine coming off of the number 3 carbon. So this would be 3-chloro. And you can see that I have a double bond off the 1, 2, 3, 4th carbon. And so I'm going to have 4, 1, 2, 3, 4, 5, 6, 4 hexene. There's the en for the double bond, hexene, and then my oic acid. Okay, so that's what you're going to do if you have a double bond in the middle of a compound that is also an acid. Okay, so again, not a whole lot more to that. You just need to be able to recognize the nomenclature, or recognize the symbolism for it, whether it's double bond and a single bond to the OH group, or whether it's written as CO2H. Either one, that's going to be your carboxylic acid, and you name it with OIC acid. Okay, so today you can practice that.